Okay, here we go. You will see that on the board I put grade 8, study island 3ABC. Now, 3A is exponential expressions, 3B is square and cube roots, and 3C is scientific notation. So after the lesson, what you'll do on Study Island is to go to section 3A, B, C, and do the follow-up questions that you'll see in those three areas. They'll probably give you 10 questions each. And so you can track your score, and we'll see how well you understand it, and we'll determine whether we need to go back over it again, which you can use the video a second time. So first we'll talk about exponential expressions. So I'm going to write down exponential here. E-X-P-O-N-E-N-T-I-A-L. Expressions. It'd be good for you to write this down yourself so you can stop the video, write it down, and then start the video back. So there's no rush. So this is the first thing we're going to talk about. I want to highlight it just so it might show up a little bit better on the video. So what is an exponential expression? So the first thing we have to do is make sure we understand the vocabulary that we're talking about. An exponential expression is an expression that's written in the form of A, B. Or I could have changed it another way. I'll show you that afterwards. But AB, where A is the base number, B-A-S-E number. You should write these things down for yourself. That's the base number, and the B is the exponent. E-X-P-O-N-E-N-T. So what does this mean? The base number and the exponent. Well, the base number will be a number like 1 through 9, and the exponent will be also a number 1 through 9. And what it explains to us, which is not that complicated, the exponent, and I'm going to write this down, the exponent number tells us how many times the base number will be used as a factor. So I'm going to write that down. The exponent, E-X-P-O-N-E-N-T, tells me, or tells you, how many times the base number will be used as an exponent. How many times the base will be used as an exponent. Will be used as a factor. I'll explain this to be very simple, as a factor. I'm going to write the factor in the red color so you know it's kind of highlighted. Now this may sound difficult, but it's really not. So let me say it again and repeat it. So the exponent, which is the number above the letter, the exponent tells, I should have put an S here, tells me how many times the base will be used as a factor. See, I should have made this used as, A-S, a factor. So you want to get the definition right, because the more you repeat it, correctly, the quicker you'll understand exactly what it means. So let's see what this is meaning. So if I say exponential expression AB, now in real numbers, it might look like this. Instead of AB, like that, I'm trying to make sure I get a really good marker so you can see very well. AB, instead of that, it will say 2, 3. 2 raised to the third power. So what does this mean? What does this say? This 3 tells me that the number 2 will be used as a factor 3 times. So what does that look like? It's 2 times 2 times 2. So the number 2, the base number, is used as a factor 3 times. 1, 2, 3. So I multiply 2 times 2 is 4, and that 4 times 2 is 8. So 2 to the third power equals 8, because 2 will be used as a factor 3 times. So what would this mean? 2 squared. It means that 2 is used as a factor 2 times. 2 times 2 equals 4. Or let's take a different one. What if I had 3 squared? That means that 3 is used as a factor 2 times. So it's 3 times 3 equals 9. So it may seem like 2 to the third power and 3 to the second power should be the same, but they're not. Because 2 multiplied by itself 3 times makes 8. 3 multiplied by itself 2 times makes 9. So, of course, if I change this around, it's still the same thing. So what would I have if I have 4 to the third power? That means 4 used as a factor 3 times, or 4 times 4 times 4. So 4 times 4 is 16. But 16 times 4 again is 64. So you see how quickly the number grows if you raise it to a power. So the number 2 has a special name. It's called square. S-Q-U-A-R-E. So 3 squared, we put a D on it. So this is 3 squared. This is 2 squared. The number 3 has a special word that's called cubed. C-U-B-E-D. 4 cubed. C-U-B-E-D. So 2 and 3 are the only ones that have special names. All the other numbers will be said to be powers. So if you have 2 to the 4, it'll be 2 to the 4th power. Power, P-O-W-E-R. Just like the TV show Power that 50 Cent was involved in making Power, that TV program. So the first 2, number 2 is called squared. Number 3 is cubed. So we have the second power or squared, third power or cubed, and then others are just powers. So what it means now is the base number and the exponent tells me how many times that base number will be used as a factor. So I'm going to maybe stop right here, pause the tape for just 1 minute, like you would do if you were watching it, which would give me time to clean the board off and go to the next part of this exponential conversation. So I'll be right back.
In the beginning, all tales and stories belonged to Nyame, the sky god. But Kwekwanansi, the spider, yearned to be the owner of all the stories known in the world. He went to Nyame and offered to buy them. I am willing to sell the stories, Nyame said, but the price is high. Many people have come to me offering to buy, but the price was too high for them. Rich and powerful families have not been able to pay. Do you think you can do it?
I can do it. What is the price?
My price is 3 things, the sky god said. I must first have Mobro the hornets. I must then have Onini the great python. I must then have Osibo the leopard. For these things I will sell you the right to tell all the stories.
I will bring them.
He first cut a gourd from a vine and made a small hole in it. He took a large bowl and filled it with water. Anansi went to the tree where the hornets lived. He poured some of the water over himself so that he was dripping. He threw some water over the hornets so that they too were dripping. Then he put a bowl on his head as though to protect himself from a storm and called out to the hornets.
Are you foolish people? Why do you stay in the rain that is falling?
Where shall we go?
Go here in this dry gourd.
Thank you, thank you, thank you.
Thank you, thank you, thank you.
The hornets thanked him and flew into the gorge through the small hole. When the last of them had entered, Anansi plugged the hole with a ball of grass, saying,
Oh yes, you are really foolish people.
He took the gorge full of hornets to Nyame, the sky god. The sky god accepted them, saying, There are 2 more things you will need to bring. Anansi returned to the forest and cut a long bamboo pole and strong vines. Then he walked towards the house of Onini the python, talking to himself. He seemed to be talking about an argument with his wife.
My wife is wrong. I say he is longer and stronger. My wife says he is shorter and weaker. I give him respect. She gives him less respect. Is she right or I am wrong? I am right. He is longer. I am right. He is longer.
Why are you arguing this way with yourself?
I have had a dispute with my wife. She says you are shorter and weaker than this bamboo pole. I say you are longer and stronger.
It is useless and silly to argue when you can find out the truth. Bring the pole and we will measure. So Anansi laid the pole on the ground and the python came and stretched himself out beside it.
You seem a little short. A little more.
I can stretch no more.
When you stretch at one end, you get short at the other. Let me tie you so you don't slip. Onini, it turns out my wife was right, and I was wrong. You are shorter than the pole and weaker. My opinion wasn't as good as my wife, but you were even more foolish than I. You are now my prisoner.
Anansi carried the python to Nyame, the sky god, who said, There is one thing more. Osibo, the leopard, was next. Anansi went into the forest and dug a deep pit where the leopard liked to walk. He covered it with small branches and leaves and put dust on it so that it was impossible to tell where the pit was. Anansi went away and hid. When Osibo came prowling in the black of night, he stepped into the trap Anansi had prepared and fell to the bottom. Anansi heard the sound of the leopard falling, and he said,
Ah, Osibo, you are half foolish. Osibo, what are you doing in this hole?
I have fallen into a trap. Help me out.
I would gladly help you, but I'm sure that if I bring you out, I will have no thanks for it. You will get hungry, and later on, you will want to eat me and my children.
I promise, it won't happen.
Very well. Since you promise it, I will take you out.
He bent a tall green tree toward the ground, so that its top was over the pit, and he tied it that way. Then he tied a rope to the tip of the tree and dropped the other end of it into the pit.
Tie this to your tail.
Osibo tied the rope to his tail. Then Anansi took his knife and cut the other rope. The one that held the tree bowed to the ground. The tree straightened up with a snap, pulling Osibo out of the hole. Osibo hung in the air, head downwards, twisting and turning. As he twisted and turned, he got so dizzy that Anansi had no trouble tying the leopard's feet with vines. Anansi took the dizzy leopard, all tied up, to Nyame, the sky god.
Here is the third thing. Now I have paid the price.
Kweku Anansi, great warriors and chiefs have tried, but they have not been able to do it. You have done it. Therefore, I will give you the stories. From this day onward, all stories belong to you. Whenever a man tells a story, he must acknowledge that it is Anansi's tale. And that is why in parts of Africa, the people love to tell and love to hear the stories they call spider stories. And now, you have heard one too.
Now we're continuing. You see, I've written here square, cube, roots. So now this is almost just the opposite of what we just talked about in square and cubes. So it's not difficult either, but it requires its own vocabulary. And it has a way of looking at things. So square root is one thing, cube root is another thing. So let's look at the square root first. So let's say we're talking about square root. Square root has a symbol, it looks like a division sign, but it has a little slanted front to it. And let's say we have the number inside, let's say is 16. And if there's nothing here, we know it means square root because we don't see anything. So what does the square root mean? The square root means that I'm looking for a number that could be used as a factor 2 times to make the number inside the square root. So now what does that mean? That means I'm thinking of what number multiplied by itself or used as a factor 2 times will equal 16. So another way to think of this is I'm trying to figure out what would the a and b exponent and base number be to make 16. So I can see that if this was 4 and that was 2, 4 to the second power means 4 used as a factor twice makes 16. So then I know that the square root of 16 is 4. Because 4 times 4, or 4 times itself, makes 16. Now that's easy for you, because let's say if we just did the perfect ones. I say, what is the square root of 2? Or, what number times itself makes 4? You say that's 2. What is the square root of 9? What number times itself makes 9? You say 3 times 3 makes 9. 16 we know, right? We just did it over here. That's 4. So what is the square root of 25? You know that automatically. 5 times 5 is 25. What is the square root of 36? You know that. 6 times 6 is 36. What is the square root of 49? You say 7. What's the square root of 64? You say 8. What is the square root of 81? You say 9. And what is the square root of 100? You say 10. So all of these we call perfect squares because they're the counting numbers, basically. So these are all my perfect square roots. I'll need those most of the time. That's why we would want to learn them so we know exactly what they are. So the square root again is trying to determine the number that's under the square root sign, what number squared or used as a factor twice will equal the number inside. That becomes the square root. So now I'm going to give you just one short step away from that. So if it's written like this, that's the cube root. That's this part, the cube root. So if the square root means what number multiplied by itself or used as a factor twice makes the root, you say 5 here. This is saying the same idea, just one step further. What number times itself 3 times will make the number inside? So let's say we had an example. I say, what is the cube root of 8? In your mind, you say, that means I have to figure out what number used as a factor 3 times will make 8. That's pretty easy because 2 times 2 is 4 times 2 again is 8. So the cube root of 8 is 2 because 2 times 2 times 2 makes 8. So I need 3 factors that will make 8. So what if I ask you, what is the cube root of 27? I have to put the cube root to make a cube root. So that means what number times itself 1, 2, 3 times will make 27? You say, well, that's not that hard because 3 times 3 is 9. 3 times 3 is 9. And 9 times 3 one more time equals 27. So the cube root of 27 is 3. So now we have the perfect square roots, and we could generate the perfect cube roots too. We could say the 2, then 3, then 4. 4 times 4 is 16, and 16 times 4 once more is 64. So see, we could have 2, 3, 4, and we could keep going up. So now we have square and cube as exponents, and square root and cube roots as roots, which is just the opposite of exponents that we did at first. So I'm going to leave this for right now and let you listen to this over and over until you follow it okay. And when you go to work on the problems, you'll be able to see what we're talking about. So I'm going to stop this, clean the board off, and be able to keep going.